Welcome to solverfy.
This problem is a parallel circuit, and it has an independent, a dependent current source in it, and it has a couple of branches with resistors in it. And so we're just going to use Kirchhoff's current law, which says that in any particular node, sum of the currents is equal to 0, or the currents coming in are equal to the currents going out. The other thing that we're going to rely on is that the voltage drop across each of those branches is the same, and I'm just going to call that V sub S. It's done that way in other problems as well. So I'm just going to say that across each of those branches I have a voltage drop of V sub S. So now I can pick a node and I can get to work. So I'm going to pick the top node on the left-hand side, and out of that node I have the voltage source. So I'm going to call that positive, or the current source rather, and that is 2V sub x over k. That's coming out of that node. Also coming out of that node, I have a branch with two resistors, 1 and 2 kiloohms, and I know that the voltage across it is V sub s. So the current there is V sub s over 3k, over 3 kiloohms. I also have 12 over k amps coming into it from that next branch to the right. So minus 12 over k, and then the last branch on the left, I have current coming out of the node, that is Vs over 6 kiloohms. The other thing I know is in that second branch, I know that it has voltage of V sub x, that is across that 2 kiloohm resistor, and I know that V sub x is equal to 2/3 of the voltage of that whole branch, because it's 2 out of the 3 kiloohms. So it's equal to 2/3 times V sub s. And I can use that and plug that back in up here. Just to make that clear, if my branch looks like this, and I have 1 kiloohm and I have 2 kiloohms, and my voltage drop is V sub s, then my voltage drop here will be twice as great as my voltage drop there. So my voltage would be equal to V sub x would be equal to 2 times V sub s over 3. So going back over to my equation, I can plug that in. So I can say that 2 times 2/3 V sub s, and I can drop these k's out, plus V sub s over 3 minus 12 plus V sub s over 6 is equal to 0. And so, collecting all my terms there, I get 5V sub s over 3 minus 12 plus V sub s over 6 is equal to 0. And so 1.833 V sub s is equal to 12, and therefore V sub s is equal to 6.545 volts. That I can use, and I can find out what I naught is. I naught is that current in the farthest most right-hand branch. And current is equal to voltage over resistance, and my voltage is V sub s, and my R there is 6 kiloohms. So I have 6.545 volts over 6 kiloohms, and so my current, I naught, is equal to 1.09 milliamps. So the only tricky thing about that is this kind of intermezzo over here that I have to do a little calculation and find out what the share of V sub s is that belongs to Vx. But beyond that, just Kirchhoff's current law and Ohm's law and a lot of algebra.